Hey everyone, welcome to the homework help video for module 17.1. I can't remember which page it's on. I'm sure I'll link that in the homework. I just wanted an excuse for you to see Oscar, so see you in the video. We are on page 833, I was able to confirm, so let's begin. We're going to be starting on this section here, 3 through 6. Speaking of problems that I want you to do, that would be 6 and 8. Those are the ones that I will not be doing on the homework help video. I'm going to be doing the odds. So for number 3, we're supposed to find two positive and two negative coterminal angles. And so just because it says positive or negative does not necessarily mean that our answers are going to be positive or negative. It just means that we're going to be either adding or subtracting one full rotation around the circle. So pause and try number 3. Okay, so fairly simple. If we have been given an amount of degrees, we're going to add 360 degrees because that's how you go all the way around the circle. We're going to do that not once but twice because we want two positive coterminal angles. We're also going to subtract 360 not once but twice because we want two negative coterminal angles. So let's give it a shot. There we go. That's our calculation. So our first positive coterminal angle will be, what is that, 444? And our second one would be, oh gosh, this looks like a 500 and 804, yeah? I should mention that these are in degrees. And those are our two positive coterminals. Let's try to find our two negative. And so we're going to do the same process only with subtraction. 360 minus 80 would be 280, minus 4 more would be 276. I almost forgot to make it negative. We're taking away more than we got, so it's negative. And negative 276 minus 360, well, we're going to really add those together, and then our answer is going to be negative. So that should be negative 636 degrees. Oops, I forgot the degree symbol. And that's our answer. Number 5. This one's given to us in radians. So, and rather than, well, pause and try it first. Sorry. Yeah, so rather than adding 360 or subtracting 360, we're going to be adding or subtracting 2 pi, because that's a full rotation around the circle in radians. Okay, so negative pi, sorry, Oscar's playing around over here, sorry to hear him. Negative pi over 3 plus 6 pi over 3, because 6 divided by 3 is 2, right? So that's 2 pi. Oh, and he was on something, and he leaned back, and it fell over on top of him. Don't worry, he's fine. It was just an egg carton. Don't ask why I have an egg carton in my work. It's for him, okay? Okay, it's fine. It's his play toy. He used it to try to crush himself. He's fine, though. Okay, so anyways, negative pi over 3 plus 6 pi over 3 is going to be positive 5 pi over 3. Oscar, I'm trying to work here. I tell you, he has no respect at all. That's all right. And let's try this. We're going to take 5 pi over 3, and we're going to add 2 more pi to see what our next positive coterminal angle will be. All right, so 5 plus 6 is 11, and that's going to be our answer, 11 pi over 3. So those are the two positive. Let's try to find our two negative. Same process where we're going to be subtracting 6 pi over 3 rather than adding it. Oh my goodness. You just dropped it on the floor. Okay, it's fine. So here's our two negative coterminal angles, negative 7 pi over 3 and negative 13 pi over 3. I gotta tell you, Every time Oscar drops something on the floor, he looks down at it like shocked that it's no longer where he had it, you know? It's like he's surprised by gravity every single time. Anyways, now he's on the floor trying to pick up the things that he threw on the floor previously. I guess he's not done playing with those. So that's it for this section. Let's move on to number 7. So pause and try that. Well, I guess we need to know what we're doing, right? So we're taking each measurement in either degree or radians, and we're going to convert it into the other one. So 7 is in degrees, 9 is also in degrees. Oh, that's right. There's more problems to this section, aren't there? In fact, I'm going to grab those problems first. Sorry about that. Okay, here we are on number 7. Like I said, 7 and 9 are both in degrees, 11 and 13 are both in radians. I want you to do, what did I say, 6 and 8, correct? I'd also like you to do 12 on your own. So yeah, number 7, pause and try it. And we are going to take this 70 degrees, turn it into radians. We are going to do that by multiplying by pi. After all, radians is measured by pi. So we multiply by the thing that we want to turn it into, right? As like any other unit conversion. And we divide by the thing that we're trying to cancel. So it's in degrees. We want to cancel those degrees by dividing by 180. Okay, so 70 divided by 180 times pi, that's going to be our radians. We could just do this directly in a calculator and get an answer. It's approximately 1.22 radians. But that's typically not how we write radians. We write it as some fraction or decimal times pi, just so it gives us a better idea of how far around the circle it is. After all, it's 1 pi all the way around the circle. But you know, what is 1.22 radians? How much of pi is that, right? So anyways, let's go ahead and try to simplify 70 over 180, and then we're going to just multiply that by pi. Okay, so another reason that we don't want to just put that in the calculator and just say, oh, it's 1.22 radians, you know, because that's an approximation. Anytime that you're involving pi and you actually multiply with pi or divide or whatever, then you're going to get an approximation. This is an exact answer. It's exactly 7/18 of 1 pi. So 7/18 of, you know, around the from one side of the circle to the other. So almost halfway, not quite though. Okay, so that's number 7. On number 9, go ahead and pause and try that one. So this one is negative 945 degrees. Doesn't matter how big and ugly the number is, we can still work with it, and we're going to do the same process. Times pi, divide by 180. So let's rewrite this. All right, so that would be negative 21/4 pi. If we so chose, we could, in theory, you know, simplify this a bit, maybe turn it into a mixed number so that we have a better idea for what that is. Turns out this would be like, you know, 2.5 times around the circle. We could also use the idea of, oh gosh, just the previous section. You know how I am with words. Words are hard. We could use the idea of coterminal angles to find out a better name for this. Just keep adding 2 pi's until we get, you know, a proper sounding angle measurement rather than negative 21/4. But that's not what it asks us to do. We're just doing a conversion, and so we can leave it there. Number 11, this one is in radians. Let's change it into degrees, so pause and try it. Okay, so unlike the previous ones, we're not going to be multiplying by pi, because this time we're trying to cancel pi, not add it into the answer. So we're going to be dividing by pi and multiplying by 180. So at least these will cancel nice and even every time. I can also see that 18 and 18 will cancel, and I'm going to be left with 10. And then 130 times, what? 130? 33 times 10 is going to equal 330 degrees. Nice. That calculation is much simpler. Okay, number 13, pause and try it. Same battle plan. Let's multiply by 180. That's the degrees that we want to turn it into. And let's divide by pi. Cancel, cancel. This leaves us 60. And 5 times 60 is 300, so this is exactly negative 300 degrees. Okay, so you know the ones that you're supposed to do, 6, 8, and 10. I leave those for you, so I wish you the best of luck. I'll check on your work, and I'll get you some feedback. I will. I promise I'll do better. So good luck on those. Come talk to me with any questions you have, and I'll see you next time. Bye-bye.